All right. Mechanical test, or we call it disruptive test, DT. Yeah. All right. So what mean by disruptive test? Destruction of welded unit or by cutting out selected specimen in order to carry out mechanical properties. Mechanical properties like we're looking for tensile, toughness, hardness, ductility. So that is mechanical properties. So normally we carry it out in WPS and also in WQT, welded test, and also sometimes problem in there is a crack, example in the joint, then they will cut out and then send for mechanical test to see what's the problem there. All right, for example, here in one plate, they cut into different sections in order to do a different test. Okay? And from this mechanical test, we have two groups of the test. One, we have quantitative. The word quantitative here referred to as from quantity, basically. When he say quantity, they got unit. Yeah? And that's to measure mechanical properties. Mechanical properties here we are referred to tensile, toughness, hardness. So how to get tensile? So we have transverse weld joint. Transverse weld joint, this is what normally we do in WPS. Or wear method tensile, this is what we normally use for checking consumable. Electrode, fill a wire, then they do all this all-wear method test. Toughness, normally for WPS, we use CHAPI, but I need you to read from the course note, refer course note. And refer course note, and please read more about the CTOD. Question will be asked. Yeah? In exam, they ask you about CTOD, but in this slide, they not mention about CTOD. They not detail about CTOD. But basically, CTOD for material toughness, checking material toughness. But I need you to read from the books, the TWI books. Course note. Please read. They ask you about this, CTOD. Okay? Harness test, we have Brenner, Rockwell, and Vickers. Normally for WPS, we use Vickers. Okay? Another mechanical test is qualitative, from the word quality. What purpose of quality here? Qualitative, assessing weld quality. Assessing weld quality basically is referred to finding defects only. Finding defects. You're looking for defects only. So that's the purpose of qualitative. Okay? All right, so we have macro and bend. This is what normally we found in required in WPS and also in welder test. Sometimes in the standard or specification, WPS or WQT, they ask you to do macro or bend. Yeah? Another two here, that's for WQT only, welder test. All right, please copy this one. All right, finish. Okay. All right, we move to the next slide. All right, in these mechanical properties of wear metal, as far as I know, in your CSWIP, they will not talking about malleability, never. The only thing you need to pay attention at ductile, toughness, hardness, tensile. All right, ductility, ability of material to undergo plastic deformation under static tensile loading without rupture, measurable elongation. Elongation here, this is what you got in all-wear metal. Tensile. And also ductility you may got from reduction in cross-section area. That's what you got in STRA, remember? So remember guys, in order to get ductility, there is two ways. One is using tensile, all wear metal. Another one is using STRA, yeah, but they have different measurement. One from elongation percentage, another one from CSA, cross-section area, okay? Toughness, ability, method to withstand bending or application of shear. If you see the, let's say that the material difficult to bend, oh my God, it's difficult to bend, so toughness is very high. If you see a material, all right, easy to bend, all right, so the toughness is low. Okay? Hardness, they're talking about surface of the material hardness. Okay? Tensile, they are referring to maximum force required to fracture a material bar of unique cross-section area in tension, right? So only this ductile, toughness, hardness, and tensile, that is what you need to be more pay attention at, more focus. It's not malleability. Malleability, they're not really mentioned about equations, okay? That is the test sample, right? And this is again for pipes, also the same. They have cut into different sections in order to do different tests. All right, we look at harness test. Harness test, measurement of resistance of material against penetration of an indenture under constant load. There is a direct correlation between UTS and harness. So here we can refer to example stress strain curve where we have, example, we refer to percentage of carbon equivalent or percentage of carbon. We can see that if the carbon percentage increase, so we can see hardness increase and also the UTS also increase. So that is mean by correlation. So there is a relation between these two. Yeah. So in hardness test, we have Brenner, Vickers, and Rockwell. So in harness test here, say measuring harness different area of weld joint. Remember when they talk about weld joint, the test must be carried out in parameter, HAZ, and weld meter. So that means by weld joint. Weld joint means parameter, HAZ, wear meter. So the test must be carried out in that location. Okay? And also to assess toward brittle fracture, because brittle, remember yesterday we talked about brittle and the fracture mechanism when hardness increased, so we've got brittle, right? And cold cracking, which is hydrogen crack. Yeah. Because one of the factor, hydrogen crack, cold cracking here is hydrogen crack. One of the factor is hardness. When you got very hard hardness, then you got one of the factor hydrogen crack to occur. Yeah. All right. This is example of they take three. You get average on this top and bottom of the base metal, HAZ top and bottom, wear metal top and bottom, and also on the other side here. So that is weld joint. Base metal, HAZ, wear metal, HAZ, base metal. So that means by weld joint area, all right? Okay, and that is, all right, Vickers, they use, so this is what normally we use in WPS, all right? PQR, all right? I can put as PQR. In PQR, the mechanical test, they use Vickers. So this is Vickers. This indication from Vickers. Yeah? And this machine and Brenner, normally more to site inspection on site. It use bore, steel bore example. Sometimes they use tungsten bore. Yeah? So this is more suitable for site harness testing. Rockwell, they have two types, B for using bore and C for they're using diamond coat. Yeah, they have two types. So that is for site testing for harness. All right, impact. What purpose of impact? To check?
Toughness.
Toughness. Yeah, right. You check for toughness. And again, you see this, they talk about well-joined areas. And this is choppy V notch. Sometimes they call it CVN. CVN, they call it. They're not talking about choppy. They say equation or answer, maybe they write down as CVN. So you understand CVN, this is choppy. Okay. The well-joined area means they must test in parameter, HAZ. This is HAZ fusion line. FL is fusion line plus 2 mm, meaning must be plus with HAZ area. Fusion line itself and wear metal. Okay? That is the specimen, and this is dimension. Don't worry about this. No need to memorize the specimen size. But you need. We talked about this yesterday about brittle and ductile. Remember? So in this brittle, normally you got flat and rough surface. What does it mean? You got under brittle here, the specimen got flat. When it's break, it produces flat and also rough on the surface. Yeah? Crystalline brittle fracture. For ductile, remember, they always got shear lips and also reduction area. So this is reduction area. Then you got shear lips here. So that is shear lips. Yeah? Randomly toned dark gray. All right, so the temperature here, we can see the example we test at minus 30 degrees. We can see the energy absorbed around 28 joules. So that will give us possible brittle can occur. And if we test at higher temperature a bit, we can see that now the energy absorbed is 47 joules. So this is more to ductile. So from here, they call it transition curve. Transition temperature, right? If we test at high temperature, normally we got more ductile. The same specimen, if we test at lower temperature, they are more to brittle. Yeah? All right, this is test result. We can see that lower temperature, always you got lower energy. Room temperature or high temperature, always we got higher energy, which is more to ductile. Yeah? All right, don't worry about this reporting result and things. Everything we refer back to spec, okay? Tensile, all right, we're pulling the material. So from here, we can see that when they're pulling, then we have REL, REH, and then we got RM. So what does it mean? So RM here, remember, this is symbol for UTS. REL is lower, RE is higher. This is yield strength. All right, another thing you need to remember a bit is the below yield here, this is what they call elastic. Okay? And above here, they call it plastic. Right? When you pull a material, before yield, then the force remove the material back to original shape because it's elastic area. But if you keep pulling material above yield, when the force remove, the material will not back to original shape because it's already plastic. Plastic here means permanent deformation. It's become permanent deformation. But if you keep pulling the material until what they call it RM, resistant mechanical, so then they got UTS. UTS is ultimate tensile strength. Then it will break after that. All right, guys, please memorize a bit about this. What is the RM? What is the REH, REL? What is the elastic? Where is plastic occur? Where is elastic occur? All right, please memorize a bit. All this. Yeah, okay? Memorize. All right, we move to the next slide. So this is what the same thing. We got elastic before yield. What is it? REL, REH. REL is lower yield point. REH is upper. H is higher. It's upper. RM is UTS. It's symbol for UTS. Okay? And then we got proof stress. Proof stress apply for material which is don't have yield, such as aluminum. So they take about 0.2%. All right, remember we have 4 types of tensile here. We have transverse tensile. This is applied for WPS. All wear metal applied for consumable. These 2 tests, cruciform and short tensile test here, this is applied for STRA. Remember, STRA, this is to check susceptible to lamella tearing things. Yeah. Yeah. Okay. All right, we move. So here we can see that one is center line of the well. Then this transverse tensile, they cut transversely. So it must be include base metal, HAZ, and also where metal here, HAZ at this point, and also another base metal here. Right, so that is the cut transversely. The specimen must include base metal, HAZ, wear metal. All right. But when we talk about wear metal tensile, all wear metal means specimen they take from well only. All right, it's not including HAZ nor base metal, only well. Yeah, okay. All right, what purpose of transverse joint? To check overall strength, meaning they are looking for UTS only. Remember well joint? Well joint means base metal, HAZ, wear metal, HAZ, wear metal. Okay, that means by well joint. And we have a different shape here. For pipe, maybe they cut and machine, make it flat, very thick material, they cut into section, they call it multiple cross section. All right, this one you must memorize how to do calculation for finding UTS. Yeah. All right, so UTS, in order to get UTS, there must be a load divided by cross section. Then we have example load here, 220 kilo. All right, we got kilo here. That's why they changed to 1,000 here. 220,000 divided by cross-section area. Then you got 73.33. Remember the unit Newton, millimeter square. There is no more kilonewton because you already use here. Yeah. Remember the unit. Sometimes you got correct answer. The numbers, the figure is correct, but they will confuse you with the unit, right? And this you must memorize. And it's not rocket science formula. It's very easy, straightforward. Load divided by cross section in order to get UTS. Got it? Okay. Remember, in transverse tensile, the unit used may be Newton, PSI, or megapascal. And they only want UTS only. Remember, in transverse tensile, they only look for UTS only. No more. No other things. Okay? That's what is CSWIP. All right. All wear metal, remember, the specimen cut from well only. And then I will skip this one, then I will come back later. All right? Remember, in all wear metal, they ask for UTS, yield, and elongation. Got it? That's the difference between all wear metal and transverse tensile. Transverse tensile, they only ask for UTS only. Careful with this. All wear metal, they ask for UTS, yield, and elongation. They ask for 3 for all wear metal. 3 things. Okay? All right, example, they punch the gauge length here, 50 millimeter, and then they pull. When they pull, they will record yield and also tensile. When it's break, they measure gain in order to get elongation. So they measure yield, tensile, and elongation at the same time. So how to calculate the elongation? This one also you need to memorize. You know how to do calculation. Right. So here example, gauge length 50, increase gauge 64. So what you're going to do? So 64 minus 50, then you got 14. So that is what you got, 14 here. And the original gauge length 50. So that is what you got here. Times 100 in order to get percentage, then you got 28%. You must memorize a bit how to do calculation for elongation. They will ask you, okay? All right, remember in our method, they ask for UTS, yield, we sharing the same unit, and then elongation percentage. In our method, they ask for 3 results, UTS, yield, and elongation. 3 results, yeah? Okay. All right, this one we have discussed yesterday about STRA. Remember, this one they cut from the base metal, specimen from base metal, do the tensile, then the result must get from cross-section in order to get ductility. Remember, in this one also they're looking for ductility of the material. Okay, this elongation here under our method, ductility of wear metal. So this for wear metal, in this one for material. Okay, but again they check ductility. Yeah, one for wear metal, one for material. Okay. All right. And remember, always remember, if we got more than 20%, it's a freedom from tearing in any joint type. Okay. All right, macro and micro. All right, I will forward this because they keep repeating the same thing. All right, objective, the purpose of macro or microscopic used to give visual evaluation, cross-section of welded joint, carried out full thickness. Width of specimen should include HAZ parent plate, may be cut from start area on the welding approvals test. What the purpose? Weld soundness. What is it, soundness? Free from? So that means by soundness, free from defect. Yeah? Distribution, inclusion, number or layers of the weld. All right. What's the difference, macro and micro? Macro only looking for defects. Why? Because our magnification can be 5 times up to 10 times magnification. So that's why we look for defects only. But in macro, it say you look for defects and grain structure. Why is grain structure? Because of magnification can be up to 1,000 times. So that's why you got grain structure. So that's the difference between macro and micro. Macro, remember, only for defects. Micro, MIC, micro, only for, defects and grain structure. Clear about this? Yep. All right. And both, they call it metallography examination. All right. All right, bend. So to determine soundness of the weld zone, when they talk about weld zone, we are referring the area of wear metal plus HAZ only, no base metal, okay? Wear metal plus HAZ. So that is well zoned. Okay. So there is three types of band. Root band, when we got root outside, and inside is cap. Face band, when we have capping outside, and now root inside. Side band, they apply for over. Over 12 means 13 mm above. That's over 12. If there is still 12, root or face. Okay? Careful with the term. Don't confuse. Like this. Up to 12. Up to 12, root and face. Over 12, meaning must be more than 13 mm, then side band must be carried out. Okay? 12, root and face. Okay? Careful with this. All right, we talk about this one, the diameter of former. They got 40. 40 here, example, the thickness is 10 mm, and the former diameter must be 4 times 10. So we got 40 mm. So that is what the diameter former. The same thing goes to this, the former diameter, band former. Okay? Is it accept or not accept? Depend on the size of the defect, like this. It's break, so unacceptable. Small indication like this. Minor rupture, maybe less than 3, may be acceptable. Okay, it depends on the, later on you refer to spec, right? All right, fillet fracture, what purpose of fillet? Inspection for defects. Like this, saw cut, 2 mm notch, saw cut, and then hammer from the back of the plate, and then check for, is there any defect? That's the purpose of fillet fracture. This is what normally we found in the WQ, the welded test. All right, knee break, the same thing. This apply for butt weld. Again, looking for defects. Saw cut, hammer, and then check for is there any defects here. Okay. All right. All right, so this is the unit for quantitative. We have Vickers, Brinell, toughness, use joules, unit for energy, tensile strength, use Newton, millimeter, PSI, megapascal, but ductility here now they use 8%. It's not E anymore. They changed to 8%. Qualitative, remember, they're looking for defects. And that's why it's no unit there. Example, macro, bend, fillet wear, fracture, and butt break test. Okay? All right, don't worry about hydrostatic tests. They're not going to ask you. All right, now look at the questions. As part of your duty as senior inspector, visit the test house are common, witnessing mechanical tests, where procedure and where the qualification. And in addition, verifying the company document is also part of your role. Therefore, knowledge of TWI spec and the use of it essential to your role. Okay? Question 1, no spec. Question 2, no spec. Question 3, yes, spec. 4, spec. 5, spec. 6, spec. 7, no spec. 8, no spec. 9, spec. 10, spec. All right, I repeat one more time. 10, spec. 9, spec. 8, no spec. 7, no spec. 6, spec. 5, spec. 4, spec. 3, spec. 2, no spec. 1, no spec. Okay? All right. Now look at question 1. You notice test house the root and face bend are conducted with 50% reduction. All right. So they request normally 4T. All right. It should be 4T. But now reduction 50% here, now it's become 2T. Yeah. In the former diameter than stated in spec, what difference is made to this testing condition? So because of they reduce the diameter former, so what happened? Stress increase. So that's why the answer goes to C. Okay. Number 2, the same thing, but here they said about excess wear matter not be removed. And again, because you've got excess wear matter normally at the point of the toe, again, it will be giving the stress. Yeah. Number 3, all right, in order to answer number 3, testing has just been completed on single-sided but 10 mm, right? So we have 10 mm thickness, PA position using MMA. Which mechanical test would you expect to find within documentation? All right, look at table 8A of the spec. All right, this is table 8A. All right, so for part 12 here, transverse tensile test, specimen, transverse bend, 1 root, 1 face, because the thickness is less than 12 and below, 10 mm. So that's why we got 1 root, 1 face. Yeah. Unless we got thickness more than 13, 1, 3, then possible we only have the side bend only. Yeah. Like this one. It's a thickness more than 12, side bend to be performed. Yeah. Chappy, 1 set of 3, harness, 1 specimen, macro, 1 specimen. All right, back to questions. So the answer goes to B because this is what we have in our spec table 8A. 2 transverse tensile required, yes. Bend, yes. 1 root, 1 face, that's correct because the thickness is 10 mm. Impact test, 1 set of 3, correct. Harness, 1, macro, 1. All right. But the rest, like A, wrong, C also wrong, and D also wrong. Yeah. All right, move to question number 4. You are checking the test report for transverse tensile test on 16 mm but 12. The UTS value is 460 Newton millimeter square. Which of the following set of tensile fail? Sorry. Right, look at 17.14. For tensile testing, what we found here, When tensile testing is required, the tensile strength of the well zone of each specimen shall be equal or greater than 20% of the specified minimum tensile parameter. If the specimen break in the well method, it should be considered acceptable provided it meet requirement as stated above. Yeah? If specimen break in parameter outside the well zone, it shall be considered acceptable provided tensile strength is not less than 90%. Not less than mean minimum here. Where on top here is maximum. Yeah, right. So we do some calculations from here. All right. I say that this is weld, and this is weld. All right, and UTS value for this parameter is 460 Newton millimeter square. For both are the same. Let's say that this one is break in the wear metal, and this one is break in the base metal. Right. For the wear metal break or well zone, so they give maximum 460 times 1.2. All right, it's 20% above, but that is maximum. 460 times 1.2. So here we got value is 552 maximum. Okay. If it break in parameter, the minimum required is 90%. All right, so 460 times with 0.9, so we got 414. So that is minimum. All right, minimum value is 4.4 for parameter break and 552 for well zone. Yeah, all right. So you got that one. Back to your questions. All right, so for wear metal breaking, wear metal, maximum value is 552, right? Parameter, minimum 414, yeah? All right, so you look at from the D here, answer D. The question asks fail the test, all right? Look at D. You say fail environmental 498. 498, this is maximum, 552. So this is 498. So this is pass. It's not fail. All right, another one, parameter fail at 435. The minimum given is 414. So this is okay, it's not fail. Okay, okay. Look at C. Parameter fail at 435. This one is 414, so this is pass, it's not fail. And test to failure method at 498. We got 552 here, so this is the pass. All right, B. Test one fail parameter 420. This is 414, so this is okay, it's not fail. Test to 480. The maximum is 552 for 1 meter, so this is pass. All right, look at question answer A. So it said test one fail parameter 414. So this is minimum 414. This is still passed, not fail. But test to fail parameter 555. All right, so this is above maximum given 552. So that is a fail here. So that's where the answer goes to A. All right. Okay, we finished number 4. Now we move to question number 5. CHAPI impact test has been conducted on a 16 mm single V-bar. Then which of the following set of results would meet the specification? All right, look at 17.13. Impact energy value. All right, the thickness given is more than 12.5. Okay. Minimum average value 40. This is average value, and individual value given is 30. Yeah. All right, the answer, the best answer goes to B. Yeah. Right. The average set 40 joules, lowest individual 30. So that is matching with the table. Okay. All right, number 6. Where the qualified carbon manganese steel 10 mm thickness, MMB process using low hydrogen electrode PC position using DC negative, which of the following is the welder not qualified for? All right, we check the thickness. All right, check the thickness first. Look at table 10 and 11. So what we can see here, the thickness here, the thickness given is 10 mm, all right? So here it will qualify at this point, less than 15, qualify 5 mm to 2T, meaning 5 to 20 mm is qualified. So this one 20 mm is qualified, 6 mm qualified, 15 mm qualified, and D also 15 mm qualified. All right, we're going to check the electrode, low hydrogen here. So here, low hydrogen qualified rutile electrode, right? So this low hydrogen qualified rutile is also rutile qualified, and this is the same electrode, and this one is rutile. So it should be okay for the electrode. And look at the polarity using DC negative. For all the answer, DC negative, the same DC negative, the same DC negative, and the same DC negative. So it should be okay. The same polarity. All right, look at the position using PC position. If you look at in PC position, it's qualified PA, PB, PC. Yeah? PA, PB, PC qualified. PE only qualified, PA, PC, PE. Yeah? So that's why here we see that this one PB qualified, PA qualified, PC qualified, but this one is not qualified, PE position. All right, so that's where the answer goes to. The answer goes to D. Yeah? All right, we move to question number 7. A CHAP impact test is devised to test sample at different temperature. What does this hope to establish? The answer goes to, we know that CHAP here, we're going to find from the different temperature, we got brittle and also the CHAP, brittle and ductile. Right? So that's where the answer goes to A, right? We're not looking UTS or yeast strength, okay? And also even D, relation between hardness and tensile strength. 8, what is the RM? It's very straightforward question. The answer goes to B, UTS. 9, if the test specimen, tensile test specimen fail to meet required value, what action? All right, look at 17.1. If the test piece fails to comply with requirement of this document, one further test piece may be welded and subjected to the same test conditions. If the second test piece fails, the preliminary is to be considered rejected and new preliminary shall be submitted for company approval. So from here, we give us the answer. Bravo. All right? One more. All right, 10, last question. In the procedure qualification, 10 mm thickness material, weld PF position, when impact not specified. All right, look at 17.9, 17.9. In all cases, when impact test not required, the position of the test were qualified for all position. Here. But if there is impact, then it will narrow the qualification range or limit the qualification range. All right, so that will give us the answer C, all positions. All right.